In this session, let's see about the pneumatics. What is pneumatics? Pneumatics is nothing but a branch of technology which deals with the study and application of pressurized gas to affect the mechanical motion. A pneumatic system is a system that uses compressed air to transmit and control energy. Pneumatic systems are used in controlling train doors, automatic production lines and mechanical clamps, etc. The main components in pneumatics are compressor, FLR filter, valves and then cylinders. What is compressor? Compressor is nothing but just to provide a pressure, to create a pressure. So compressor is the heart of the system, converts electrical energy to pneumatic potential, contains a relief valve, protects compressor and system from overload, controlled by a spike relay. In the picture you can see a air compressor here. Next is FLR filter. So for here filter is used to remove the impurities that present in the compressed air before it is fed into the pneumatic components. Then pressure regulator. Pressure regulator is used to stabilize the pressure and regulate the operation of pneumatic components. Then lubricator. So lubricator is just used to lubricate the pneumatic components. So here you can see the FLR filter. This is a filter and this part is a pressure regulator and the last part is lubricator. Next, coming to the valves. Here we have 2x2 valve, 3x2 valve, 4x2 valve and 5x2 valve. These all are the directional valves we are using in pneumatics. 2x2 valve means, so totally this 2x2 valve consists of one input and one output. That's why it is called as 2x2 valve. This 2 represents the number of terms, that is on and off. So this will be common for all the valves, and these 2 represents the number of input outputs. So here we have one input and one output. That's why it is 2x2 valve. Here you can see the valve picture. One is always connected to the as an input and 2 will be as an output. So this is 2x2 valve. Next, coming to the 3x2 valves. 3x2 valves consist of one input, one output and one exhaust. Here you can see one is always an input side and 2 is always output, and here 3 is the exhaust. Here you can see the picture of the 3x2 valve here. And next, coming to 4x2 valves. 4x2 valve means it consists of one input, two output and one exhaust. Here we can see this P is used as an input and this A and B are as outputs, and this T is as an exhaust. That's why it is called as 4x2 valve. Here you can see the picture of that. And next, 5x2 valve. 5x2 valve consists of one input, two output and two exhaust. Here you can see one is as usual it's an input, 4 and 2 are output, and here 5 and 3 are considered as an exhaust. So this is called as 5x2 valve. Here you can see the picture. So these are all about the valves. Next one is cylinders. They are the linear actuators. The output motion is in a straight line, and they are basically used for pushing, pulling, tilting and pressing. In cylinders we have two types of cylinders. So one is single acting cylinder and the other one is double acting cylinder. So a single acting cylinder has only one entrance that allows compressed air to flow through. Here in the picture you can see the single acting cylinder. So it is having only one entrance, and this is the piston. So whenever you create a pressure in this entrance, the piston will move outside in this forward direction. Here also you can see the single acting cylinder. This is a piston, it will move in forward direction. Next, coming to the double acting cylinder. In a double acting cylinder, air pressure is applied alternately to the relative surface of the piston, providing a propelling force and a retreating force. So here you can see the double acting cylinder. This is one entrance and this is another one entrance, and this is the piston. So whenever you create a pressure in this entrance, the piston will move in the forward direction, and whenever you create a pressure in this entrance, the piston will move in a reverse direction. Here also you can see this is a piston and these two are the input ports. So whenever you create pressure here, the piston will move in the forward direction, and whenever you create pressure here, the piston will move in the reverse direction. This is all about the cylinders. Next, another one valve we are having, that is a shuttle valve. So shuttle valve is also known as double control valve or single control non-return valve, because it will be acting like a OR gate. So here you can see there are two inputs, that is input 1 and input 2. So if you create a pressure in input 1 also, you will get an output here, or you can create a pressure in input 2 also, you will get an output. Here you can see the block. So whenever you create the pressure in P2, this block will block the P1 input, and whenever you create a pressure in P1, this block will move this side and it will block the P2 input. So you can pressure at any one side also, you will get the output. This is all about the shuttle valve. Next, coming to the general methods in pneumatics. Here we have clamping, shifting, positioning, orienting and branching of material flow. These are some general methods, and where we are using pneumatics means we are using in packaging, filling, metering, locking and driving of access, door or chute control, for example like bus doors, train doors, anything. Then transfer of materials, turning and inverting of parts, sorting of parts, stacking of components and stamping and embossing of components. So these are all the applications where the pneumatics is used. This is all about the pneumatics.